Ever look at the forecast and think, how can they miss tomorrow's weather, but still know for sure that the weather in July is going to be hotter than in January, or that global temperatures are rising year after year? The answer is the zoom button. In this video, we'll watch one temperature line go from the scale of a single day to weeks to seasons and finally to long-term climate. Same data, different time scale. And here's the cool part. There's a moment where the squiggles stop looking random and start looking predictable. When you see it, weather versus climate finally clicks, and you won't be able to unsee it. Welcome to Untamed Skies, where science meets humanity. If this kind of sky science is your thing, subscribe for more. The National Oceanic and Atmospheric Administration sums it up like this. Climate is what you expect. Weather is what you get. In other words, weather is what happens from minutes to days to weeks. Climate is the average pattern over seasons, years, and decades. So let's see that in action on a graph. The vertical axis is temperature. The horizontal axis is time. The orange line is the temperature, what the thermometer records. All right, watch the orange line. Zoomed in, it looks jittery, but that noise is real. Sun, shade, clouds, wind gusts, and the ground heating and cooling all cause the temperature to go up and down throughout the day. Even if the weather doesn't change much, temperature naturally rises after sunrise as the surface warms, then falls after sunset as the ground loses heat. This is what's called diurnal variability, or the daily cycle. So one big up and down doesn't mean a new climate. Sometimes it's just Tuesday. Now we zoom out to multiple days. The daily wiggle is still there, but the whole line starts drifting. All the wiggles are trending up. That's because the air mass that you're living inside is changing. Here's a warm front, which is literally the front side of a warm air mass as it moves in. So the average temperature rises. Both days and nights trend warmer. Notice how the daily or diurnal cycle is riding on top of the bigger, slower change. As the time window widens, you start seeing layers of weather. Daily heating and cooling, plus multi-day trends and systems. This is why you can have a warm afternoon inside an overall cooling trend, or a chilly morning inside an overall warm-up. And now you see a cold front sweep through. Like the warm front that ushers in warm air behind it, the cold front ushers in cold air behind it. So you see an overall cooling trend over several days. These frontal passages are part of what we call synoptic variability. Large-scale weather systems swapping out the air you're breathing. Now, we zoom out to the time scale of weeks instead of just days. A week is long enough to feel the rhythm. Warm spells followed by cold snaps, rinse and repeat. But watch what happens as we keep zooming out. The day-to-day wiggles shrink visually. Not because they stopped, but because they're no longer the main story at this scale. That's the big first lesson. Weather is noisy. Climate is the steadier pattern you see when you step back. Now, as we zoom out to the scale of months, we see that weather still happens. Heat waves, cold snaps, but we start losing the detail of your day-to-day experiences and instead can only say things like, it's warmer than normal, cooler than normal, or stormier than usual. This is when we cross the bridge from thinking about weather to thinking about climate, turning many weather days into a statistical average, range, or anomaly. And notice, as the zoom continues, the temperature line starts to show the seasonal changes. You see the temperature gradually fall during autumn, then rise in the spring. The atmosphere is still throwing curveballs each hour, each day, and each week, but the calendar is quietly steering the average. The daily changes become barely noticeable on the seasonal timescale. Once we hit a year from when we started and continue zooming out, we see that the dominant temperature swing is the seasonal cycle. At this scale, the warm and cold fronts don't even matter anymore. Temperatures rise toward summer and fall toward winter because sun angle and day length change throughout the year. This is the heartbeat of the climate. Finally, when you zoom out and look across many years and decades, we enter the realm of climatology, the what you expect part of our story. The repeating temperature pattern becomes a baseline of average temperature and expected temperature ranges at a particular spot on Earth, affecting everything about life at that location, from the biology of species to agriculture to transportation to entire economies. And if that entire temperature line of repeating waves slowly shifts warmer or cooler over the decades, that's what we mean by climate change. Not one spike, not one storm, not one heat wave or cold snap. Climate change is when that entire baseline of average temperature moves. This is why a really bad hurricane can't necessarily be blamed on climate change, but is also why an extra bad cold snap in the winter doesn't mean climate change isn't happening anymore. Climate change affects every type of smaller scale weather, but a single small scale weather event can't necessarily be blamed only on climate change. The big picture is made up of a bunch of smaller pictures, so looking at just one of the small pictures often isn't enough to infer the big picture, even if each of the small pictures contributes to the big picture. This nuance is often lost in political discourse because it doesn't lend well to tweets or 30-second sound bites. Another way to think about it is climate is like a loaded set of dice. Weather is each roll. One roll can be anything: cold, hot, stormy, calm. But if the dice get even slightly loaded, over hundreds of rolls the odds change and the averages move. That's what long-term global warming is. A shift in the odds. not the removal of cold winter days. So that orange line that we followed contains all of it. Daily ups and downs, diurnal cycle. Swings between warm and cold fronts, synoptic weather. The seasonal cycle, climate. And long-term shifts in the baseline average, or climate change. Climate is what you expect, weather is what you get. Weather helps you decide what to wear tomorrow. Climate is how you decide where you might prefer to live. It helps farmers plan crops, cities manage water, engineers design infrastructure, and emergency managers prepare for what's likely over the long haul. So yes, snow can happen in a warming climate. A cold snap is still weather. Climate change shows up when over many years, the odds shift. Heat becomes more frequent, cold becomes less frequent, and normal quietly move, almost without us noticing. Under the untamed skies, we live inside the squiggles. But when you zoom out, you see the overall pattern. And now you'll never see weather and climate the same way again. Drop a comment below about what else in your life might benefit from a simple shift in perspective. And subscribe to Untamed Skies for more explainers that connect the science to real life. See you in the next one.